talk on Sound, they're going to chat about a very interesting architectural journey they had Moonpig. So please welcome them with a big applause.
Hi everyone, thanks for coming down. I hope you're all enjoying our space. I'm sorry we ran out of pizza in about 10 minutes, and it looks like we ran out of booze, so I'll remember that next time. So we want to talk to you today about the architecture patterns that we've kind of been through and how we've ended up with MVI and where we've ended up and why we've ended up with it. So I used to work for IBM. I worked for a bunch of brands whilst I was there: BP, Castrol, Waitrose, Barclays, quite a few. And yeah,
Are you going to tell what you do here?
oh yeah, and I'm a mobile leader.
So I'm Todd, I'm an Android dev here at Moonpig, and yeah, I used to write some really bad banking apps, and so I've used any of them, and I did some other stuff before that. I don't really know how any of them, and I did some other stuff before that. I don't really know how Keynote works. So I had a lot of fun with animations. So yeah, we're going to start with a bit of a history lesson. So we're going to run through like the journey that we went on to get to MVI and the problems that we identified along the way and the reasons that we, I wouldn't say settled on that, but the reasons that we got to that point so far. So the Moonpig Android project started about 4 years ago, and right from the beginning we had a big focus on quality. And I won't say that we had these 5 things from the beginning, these are just bullet points I made up, but these are the kind of the things that we try and have whenever we write code, and it spells trims as well, which is a word. So yeah, basically, we have tests on everything. We want to be able to release regularly. We try and release every couple of weeks. We want to be able to move quickly, add new features, change existing features, and we want to be able to scale it up when we get more users. So that's the stuff that we look at. Cool, so just a few things to keep in mind when we look at the history of how we got here. So what we're talking about here is mostly presentation architecture. So MVC, MVP, MVI, there's maps that you've heard of probably. There's also like app architecture, clean architecture, that kind of thing. We're not really talking about that so much, but obviously they do interact to some extent. When we talk about these various MVX patterns, they vary in terms of how people implement them. You look online, you'll find different versions of them. So like, if you're saying they're thinking that's not MVC, yeah, you're right, there's different ways of doing it. And also, like, this is a bit of a simplification, of course. We iterated a lot as we went along, and like, I'm just going to find the diagrams and such. So, where did we start out 4 years ago? Well, I joined 3 years ago, but when I joined, the app mostly looked a lot like this. So this is what we might call MVC. We had an activity, which was our controller, and the controller has a view, and in this case, I've just shown a dispatcher, but you can think of that as kind of the rest of the app. So anything else that we wanted to call out to was all done straight from the activity out to whatever that might be. And this doesn't really have many good things to say about it. Probably the main one is that you can write on your CV that you're an architect. But it has a big downside, which is that in order to test the activity, which has got all of your business logic in it, you have to use Roboelectric, and Roboelectric's really slow, and whenever it updates, it doesn't work very well, so we realized quite quickly we didn't like Roboelectric. The other downside is that the controller is basically the king of everything. It's a massive ball of messy code, and the worst problem of all is someone comes along and rotates the phone, and basically the whole thing falls apart because the dispatcher doesn't know where the controller went, and then the controller needs a UI, and you're the smart architect, and you're like, don't worry, I put everything in the bundle, but you probably forgot something, and then it crashes. So we kind of said, how can we improve on this? So what we said is, what about if we simplified the way that the view is applied to the way that the state is applied to the view? So we said, we'll just have this really simple enum, right? And it'll just represent each of the states that the view can be in. And it'll be really, really easy. And you just, it's always in one of those states. And that was what it was supposed to work like. And then, like, after a while, it ends up looking more like this. Because your designer comes along and goes, yeah, but actually, I wanted this error message to be green, not like the others. So what actually happens is that that's not really true, and then, well, that's not really true, and then this whole thing basically didn't work out very well. But there was one good thing about this, which was that this idea of having view state contained in one object that you apply is actually something that we came back to with MVI. So maybe the problem is this bit. So how do we solve that? So we went to MVP, and you might notice here that we're also now using clean architecture and RxJava. I'm not going to talk about those too much, but yeah, that also solved some of the problems that we had in the rest of it. So you can see now that we're separating out like the different parts. So this means that it's much easier to test because there's less code in any one place. And the other great benefit is that we don't have roboelectric anymore because our view is really dumb and we don't need to test it, we just use espresso test for it. So all of our business logic is now presented and we can unit test it without roboelectric. So questions we had to answer, where does the state live? We briefly tried putting it in the use case, don't do that. You can push it down to the data source, but then you've got to add databases and things which we don't really have, so we ended up keeping it in our presenter. And we did that with introducing Dagger, and we basically just had like Dagger components. The Dagger component scopes to the activity, so if someone rotates the device, you keep it in that on-view state retain instance method thing. And it basically, you get the same presenter back from Dagger. But the presenter still has a lot of responsibility in here. So it's updating the state onto the view. When it rotates, it has to reapply all of that state and make sure that you ended up exactly back where you were before it rotated. It has to get things out of the view. It also has to make decisions about like what use case methods you're going to get called. And now we've got RxJava, so we're managing the subscriptions on the use case as well. So we move to MVI. Now, for the details of how this works, we're going to talk about a bit more about that in a minute, but just to cover like the differences from MVP. So the rest of the architecture's over there, I just got rid of out of the diagram to simplify things. So we extracted what we call the renderer, and what this does is it takes the view state, the representation of what's currently on the screen, and it applies it to a view. So now that's one less thing we have in the presenter. And you notice also that the view is now observable, rather than the presenter having to make calls in and out of it. So if you think about the 5 things that I said just now are in the presenter, well, we no longer have to get data from the view because this gets pushed by the view because it's observable. And we no longer have to reapply the state in the presenter because we've extracted that into the renderer. So we straight away we've simplified that. And also because of the way that MVI works and the way that we built it, these two get simplified as well. And we'll talk a bit more about that later. So the first time we did MVI, we found a library called Mosby by a guy called Hans Dorfman. There's a really good set of blog posts he wrote on MVI, there's links at the end. So we needed like a base presenter which has all of this logic for containing our state, and we used Mosby for that. Just hands up if anyone gets that joke. The rest of you are like, what? Yep. So it's quite a big library, there's a lot of things, and we didn't want all of it as a dependency, so we actually just like copied 2 classes out of it. And it was really good because it allowed us to move fast because we didn't have to write this like base presenter. And we were trying out MVI for the first time, so it was a good way to start. But it had some problems. So these are all in the base presenter that we took out of Mosby. That's a spelling mistake on the 3rd line of the class, which is always a good start. There's these weird lit errors. Is that a problem? I don't know. I didn't write it. There's to-dos in it. And the whole thing's like 450 odd lines of code. So we weren't totally happy with it. So why did we decide to change the implementation? Well, firstly because we needed something to present, and mostly because of the things I just talked about, and because we just copied the code and we weren't really going back and updating it either. Dagger scope is a little bit complicated, but Dagger scope only survives when you rotate the activity, not when the activity goes away because of memory issues. So that's a weakness of us positioning the presenter in that way. We also just really want to simplify it and understand it better. and obviously apply like lessons that we learned while we were going along. And as a bonus, we started using Kotlin, so we wanted to make better use of some of the more idiomatic Kotlin that we learned. And we wanted to see if we could use some of the new Android architecture component stuff, because we used it for a hackathon, we quite liked it. So this is our second implementation. It's pretty similar, except the presenter is now a view model. So that's like an Android architecture view model. It's now about 45 lines of code. Sorry, I'll just skip that one. It's now about 45 lines of code rather than 450, so that was great. And the scoping and restoration of state works much better. So, that's a quick history lesson. Now we're going to talk about MVI in a bit more detail.
Okay, so when we were putting this all together, we were trying to understand what we didn't want to just go over MVI. You can kind of read about it in lots of places. We wanted to talk about what was powerful about it, and I think these are three of the things that give you a lot of power with MVI. So one is reactive streams. I'm not going to talk about that too much. It's a topic in its own right. I think it's fairly established now in the sort of the Android world. But we have mutability and we have unidirectional data flow. So I'm going to kind of just give some examples to talk through what that really means. So we have this architecture, we have our view, our presenter, which we should probably change that to view model, but you know what it means. And I'll render out my use case of data source. So that's clean architecture on the right. We're not going to go into too much about that, but I want to show you kind of a life cycle of a unidirectional data flow and how it works. So we have our view, it's the activity, it's a fragment, and it's intents. Intents are user intents. What's the user doing on that screen? So it might be like a button click. The presenter then takes that intent and it maps it to an action. The use case then side effects out, does something with that action, and it gets back a result. And then it maps that result, maps the response from the data source back to a result, gives that back to the presenter. The presenter takes the result and reduces it into a new view state. And then the renderer takes the view state and calls the corresponding view methods on it. And every intent, when it gets emitted, goes through that loop. So to give a real example, the user taps a load products button, we map that into a load products action, we side effect out and get the products, we get a products response, we map that into a products result, we reduce that into a new view state, and then we render that new view state on the view. So I realise it sounds like a lot of steps, and it sounds like we've broken it down quite a lot. You can actually break it down a lot further than this. But why do we do it? So separation, testability, maintainability, and repeatability. So what I mean by that is every layer then can be tested independently. So the view is tested through espresso tests. We keep the view simple, so it doesn't need anything more than that. Everything else is just Java or Kotlin classes, and they can just be directly unit tested. And because you're mapping between each of those states, you can very easily set up your state and test it, and it makes your test really simple, which I'll go to in a bit more detail now. So I'm going to talk about the architecture. So what do you do with your view? Your view is your activity, you keep it dumb. It subscribes to intents because it has to. That's where the user is interacting with your application. It's through the activity or a fragment. That's Android's view to the world, to the user, sorry. And then also we have to update the view back to the user through the view. So the view does two things. It subscribes those intents like button clicks, and it updates the view, i.e. visibility, showing, hiding, things like that. So to give a quick example, don't worry if you don't know RxJava too much, this is Rx bindings library, but effectively we have a button, and when that button is clicked, it emits an intent, and that's all that button does. So then we have our presenter or our view model. So again, don't worry too much about the Rx side of this, but effectively what happens is those intents come through and we map them into actions. So to give you an example, we feed an intent in here. When it's equal to a load products intent, we map that to a load products action. Then we take the action and we send that into our use case, and that's where it goes off the side effects, fetches data, whatever it does, and it responds with a result. So we take every action and we map them into results. And you'd have more states there, so you'd have like error, success, various different web states that you need. Then we have our reducer. So all our reducer does is take the result that came back from that use case and takes the previous view state and then generates a new one. So effectively, for a result of in flight, then we create a new view state. It's based upon the old one, so it's building upon it. We're using copy, which is like a Kotlin shorthand to build you a copy of the old class. And then we change one of the parameters, which is request invite to true. Then we have our renderer. So the renderer is really simple. It just takes a view state and it just makes calls on your view based upon whatever that view state is. And you just keep it really simple. So in this case, it's just a boolean. If it's true, then we call the view and tell it to show loading. If it's false, then we call it and tell it to hide loading. And then we come back to the view, so we're at the end of our loop now, and this is the show loading and hide loading methods. So it's an example of how simple these methods are, and that's why you don't really need to test them directly as a unit test, but Espresso can take care of that for you. It's just testing if something was shown or hidden. So how do we test it? So in our view, this is just an Espresso test. So we set up an activity in a certain state. So in this case, it's one that has products in it. And then we just assert that the products are displayed, and in this case, we assert that the error layout isn't displayed. For your presenter and your view model, what do you do? Well, you mock out your use case to return you a certain result or an action, and then you emit your intent, and then you just assert the values that come back for your view state are what you expect to receive. For your renderer, you simply set up a view state, put some values on there, you call the render function with a mocked view, and then you just verify that the mocked view had the corresponding methods called for that view state. So hopefully that's a quick explanation of MVI and the power of those immutable states and how it's very, very testable. So why do we do it, I guess? So yeah, it's testable. So it lends itself to TDD well as well, which is what we practice here. So in your test, you can define a state, you can define your expected outcome, and then you can just implement the code to pass that test. And we found that our development practices changed so much that we could just write out entire features through unit tests and Espresso tests, and then we didn't even manually test them until we were basically done with the feature. Quick test to make sure everything works, and then we'll send it off for a pull request. We don't have QAs in the company, so we're responsible for everything we ship. We're a small team, so we have to make sure everything is automated and as testable as possible. But this actually, funnily enough, forced us to change our ways and sped us up, because we can actually now just write everything out without even, sitting there running builds, because it takes time. The next thing is the data follows a standard lifecycle. So if you build out a new feature, because you always have that lifecycle or your intent loop, it makes it really easy to understand when someone else writes something else. You understand all the architecture and all the structure. You just need to figure out is it doing what it's supposed to be doing to pass whatever your story or your use case might be. So it makes it really simple to follow. And it makes working on complex features trivial. So if you have a complicated UI that's aggregating data from multiple sources, any of them can fail, you might have different layouts with different failures, you might have loading indications in different places, whatever it might be. Well, it doesn't matter, you just render a state to the UI, and as long as that state is mapped out correctly with a few functions, then it doesn't matter when they get updated, it doesn't matter what that state is, it doesn't matter how complicated it is. It all just works in the same way, so it makes complex logic really simple. So it decouples the Android dependencies. So I put a star there because you have to do some work to figure out the device rotations, and we're using view models to do that, but there is some other things we have to do. But you can't completely decouple Android. So for example, if you implement Google Pay works in a very specific way that expects you to call out to it and then receive the result in the on-activity result. And that doesn't really work with MVI, so you have to every time you get to something a bit Android-y like that, you have to kind of figure out what to do in that scenario, so it falls down a little bit. But generally speaking, it is powerful because, yeah, you don't have to worry about rotations and all that kind of stuff. Once you've written it, it just works. We logged the view state in our crash logs. And I don't want that to sound like we have crashes. We actually barely have any. We're 99.9% most of the time. But what's powerful about that is you can just relog the state of the user. Is if you have the user state that was logged, the view state, sorry, that was logged at that crash. So you can literally map it out and just rebuild the UI and figure out exactly what it did and exactly what went wrong. And it plays nicely with the clean architecture. It's not that important. It is to us because it's part of our engineering practices here. But it's not really an MVI thing as such. It works that way.
Yeah, I get to the negative side. So yeah, there's a few things about it that we don't like, or that we're still trying to improve. So there's quite a bit of boilerplate around setting up the subscriptions, and kind of you have this base presenter and then you have to like implement the stuff off of it. So in your activity, you've got all of these intents that are emitting button presses and things, and like you've got to merge all those together. Also, you've got to do like the view model binding stuff. So there's a bit of boilerplate around it, probably more than you would have in like a classic MVP. So relies heavily on RxJava. It's not as much of a problem now, like most people are quite familiar with it, but it is a separate library, so you can't like assume everyone knows it, and also you're building a dependency on that library, right? And like, do we know that it's going to last forever? These things don't always. When we started this project, like we put robo spice to network library in. Yeah, whoops. RxJava is probably more stable than that, but you can never be sure. So there's a bit of a steep learning curve with MVI. Certainly, if you're new to RxJava as well, it's quite a lot in one go. So especially like if you're bringing on juniors and such, that can be a difficulty, and it's something that you have to spend a bit of time with. It also requires discipline, because it's quite easy to cheat with MVI, right? You go, oh, I don't really want to write all of this, like go around the loop, and I could just do it in the activity. And then you're like, oh no, it doesn't restore properly, I'll just put it in the bundle. And it's like, now you're back with your MVC that you hated, right? So you have to have discipline to do it properly. And that kind of links to this, is that although complex features become quite easy because you just follow this code pattern, sometimes there's a really trivial feature and you're like, oh, I have to follow this whole code pattern out, and you write a bit more code than you would need to for MVP. And the last one I think we kind of talked about already, there's a plus and a minus on that, but yeah, some of the very Android stuff can be annoying. Next slide. So yeah, these are some things that we're thinking about trying to improve. So reduce boilerplate, talked about that already. We've got it down quite a lot by using view model, but we'd like to think that we can still do more. There's still more than one thing going on in the presenter. Like it's still managing the subscriptions, and it's like mapping actions, and then it's setting up the stream, and then when the results come back, it's pushing it out to the renderer. So could we extract some more of that logic? Maybe, we're thinking about that. How do you break down really complex screens? So we've tried a little bit with having like separate component views and having their own MVI loop in each one. And that works quite well for breaking it down into simpler units. But then you have to deal with communicating between them, so there's still some things that we're thinking about there and the best ways to do it. Coroutines, everyone's just loves talking about coroutines. We've not really tried them out, but we're wondering if they're useful to us. Probably not in the MVI layer, but maybe there's something in there. Can we make it more functional? This is something I've been thinking about. So, like one of the things I've seen done with MVI is instead of having this like reducer object or reducer method, you actually like put the reducing logic on the result itself. So the result knows how to map itself into a view state. So this idea of kind of like pushing the logic around, passing that between some of the layers rather than passing state around and then reacting to what that state is. And composition of inheritance. So we have base classes, which every time I add a base class, I always ask, do I need a base class? I've not come up with a solution to that yet, or maybe we need one, but if we could do it in a way where there was more composition, that might be something that we could look at. I think that is it. Yeah, there's some links on there. So we've actually open sourced the base project for our architecture. It's a work in progress. You're welcome to have a look. And there's a link missing from that. But anyway, there's another project that we used for quite a lot of inspiration, which will be on the slides. We will put them online. We'll put them on our Twitter account later. Yeah, and a couple other interesting links there as well. Yeah, I think that's it. Cool, thank you.
Are there any questions? Right there.
Are you doing code review?
You were so nice.
Are you doing code review?
Hi. Couple of questions. So first of all, about the espresso test. Did you find them, once you extracted all the logic from the activities, how valuable did you find them? And the second question is, how do you balance, like you did like 3 iterations on the architecture, how do you balance new feature work versus legacy features? Do you refactor the legacy features or not?
Cool, yeah, good questions. So in terms of espresso, we have 2 kinds of espresso tests. So the kind that we talked about here, where we're testing like a very specific, put a view state onto the view and then check that it displays in the right way. So those are quite valuable, and because they're quick to run, you can have quite a lot of them. You just have a suite of them that runs, and they're really reliable. We also have like end-to-end espresso tests where we'll go through like some key core journeys to the app. I wouldn't say that our experience with espresso has been totally painless, but it tends to be those longer ones where you're moving between screens where we've had more issues with it, and that we would have those anyway. So moving to MVI, to be honest, made our view testing easier, if anything, because your view state is I was going to use the word trans, I'm not sure if that's the right word, but your view state has everything you need to render the whole screen, right? And it doesn't matter what the previous view state was, so there's no history there. So you just need to put, this is my view state, put it on my activity, and then you can test that that shows up properly. And then it just works. The second question was?
Balancing between legacy features.
Yeah, so what we normally do is we'll find a new feature that is an opportunity to try out a new way of doing something. We don't go back and like refactor everything because that's silly. If we're going back and touching a really old screen, like if we're going back and touching an MVC screen to like make some tiny little layout change, yeah, fine, we'll just leave it. If we were making like a drastic change, we would rewrite it on whatever our new version is. And we don't think it's a problem that we have kind of 4 different architectures in the app, because if you say that that's a problem, you'll stay with MVC forever and you'll never improve it, right? So we're trying to settle down a bit now with MVI, like we're quite happy with it, and we think it's more iterative than where we've been in the past, but yeah, that's the situation.
One of the commonly stated issues with MVI is a lot of object creation. You find that you're thrashing your garbage collector and like event-heavy screens. I don't know if you have any of those, so that'll be a problem for you.
So that's a really good question. So we've done a big piece of work recently where we're rebuilding our whole basket, because previously Moonpig's a company built on selling cards, and one at a time. So we've only very recently had the concept of buying more than one thing, which sounds crazy in 2018 with an e-commerce company, but that's the way it is. So we've just done a big piece of work to rebuild the basket, and we've done that using MVI with mostly, that's the first kind of thing we've done. And the performance has actually been surprisingly okay, but we found more problems with things like we were re-rendering views even if the view state hadn't particularly changed, or it didn't need to, or sometimes you might have the same intent in there 5 times for, I'm trying to think of a good reason, but because that sounds wrong, but like basically we found more performance problems with the views repainting too much and stuff like that. So, and there was some really simple fix for that. It's basically, if you use ArcStrava distinct until change, like don't limit stuff if it hasn't changed. So there were some simple solutions. Spinners.
So the best example of where we had to do it was, we have a spinner, and your spinner has a list of items, and that list is say coming from a network call. So you go off and get your data list and you put it in your spinner, and that data list is therefore in your view state. So every time you make any other change to anything else on the screen, you're reapplying your whole view state, and you're going to like repopulate the spinner list, which you don't want to do because you'll start like moving which one's selected, or it's just not very performant. So in that kind of situation, you just have to put a little bit of like, yeah, if this is the exact same list, don't reapply it. But as long as you, with a little bit of common sense around it, it works pretty well.
Cool. Any more questions? Nice talk. How do you do navigation? Do you consider that like an action and like an intent that gets processed, or?
For like moving between screens?
Yeah.
Yeah, so this is one of the, it can be a slight gotcha because you go, oh, this is, I want to navigate to another screen, and you like put the navigate in your view state, and then you render that, and then you move out to another screen. And then that's great, and then the user hits back, and you get the same view state back, and it goes, oh, go to the other screen. You can't ever get back into the screen, right? So yeah, the way that we typically do it is, when you render that view state that says load the other screen, we do one more quick MVI loop that sets that basically clears that flag so that it won't happen again when you come back to the same view state. We got one up front.
After you choose MVI, what's the main advantage of MVI rather than MVP, MVVM? Why did you choose MVI? Do you think it's better in any reason, particular reason?
So, yeah, I mean, why we moved off of MVP, and hopefully I explained a bit of that, but like, the presenter and its interactions with the view we just found was really messy. And when you try to like change one feature, you have all these calls going between them, and it was hard to maintain. MVVM I've not really used, I'll be honest. Some people have looked at MVI and said, that's like a more complex MVVM, and you could just do it with MVVM. I'm not really an expert on that, so we kind of skipped that one over. But I think what we really liked about MVI was this idea of just having this single, simple view state that you render. You don't have to care about the history of it, and the fact that that unidirectional flow, it just simplifies all of the connections between the components. That was how I saw it.
Any more questions? Anyone?
I've got a couple, but the most interesting would be, you mentioned that you're using test-driven development. I was wondering, I remember about a year ago doing a project where I was working on a Ruby backend, and I did the backend feature, and I was using test-driven development. It's kind of 3 seconds to run the test, but then moving into Android, just testing a single class was sort of 60 seconds to run the test. So how do you deal with that kind of? Do you have a problem with it being slow to run the test?
We'd probably say not really.
So no, we don't at all, because when you're running most of that, like what MVI is that we showed you, the only part that's slow is the activity, right? Setting up your activity, getting Espresso to run, that is slow. Robo Electric is incredibly slow. In fact, we did do like an audit or a performance look at why our tests or what's bogging down most of our tests, and it was all the Robo Electric ones. So that stuff's slow. The rest of it is just pure Java or pure Kotlin. So it's instant, like it's really, really fast. So apart from Espresso, everything is rapid. And even with Espresso, because we're rebuilding like a view state and just testing like little snippets like that thing I showed where we just assert that some products displayed, and maybe you tap on one and assert that it emits it goes to the right next screen or whatever it might be. That stuff's all really fast. Our end-to-end Espresso test is slower, I would say, and that's where the baking is. But we replaced that with Appium. Appium was even worse, so I don't know, I haven't found a good solution for end-to-end automated Android testing. We're always having to deal with it. I guess it's a bit of a headache for us, but like I said, we don't have QA, so we have to have something there, and I'd rather have something that passes most of the time with the odd flaky test, that tests all our journeys, than manually testing it or missing something. So.
Do you use any kind of device farm for running tests across a lot of different Android devices?
No. No, so we do have quite a few handsets, and we could look at doing that. To be honest, we haven't yet, but we really should. And one thing we're bad at, I think, is, or definitely I'm bad at it, is you open the device cupboard, and there's all the Samsungs that pretty much all of our customers are on, and then there's all the Pixels, and I'm like, well, I'll just take Pixel. And it's really hard to be disciplined and test on worst devices that we have. Not I'm saying they're all Samsungs, but yeah. But I think so. We could. We're also even looking at the, Google have improved the emulator so dramatically. We're even looking at spinning everything up into Docker containers, so getting rid of, so we use Mac Minis as our build slaves, I guess, and they're expensive and slow. So we're looking at just having Linux containers in the cloud and then just spinning up 20 emulators of every different device type, and then maybe that works. Haven't tried it, so I'm just throwing ideas out there. But no, we're not, and we probably should be. I guess is the right answer.
You were talking about some of your screens being a composite of different views with different view models feeding into the model. I was wondering how you assemble it. Where do you get the figures? What process says, right, you need this set of view models to feed this set of views, particularly if you've got views shared between screens?
So, I might have oversold that a bit. So the only place we've done that in the app, we did it with, we're not using view models there, we did it on Moonpig. So we don't have to deal with that. And I think there's only 2 components. So it was something we tried out. It did help a little bit, but it probably wasn't totally needed on that screen. And one of them, it's really easy to do if those components don't interact at all, right? So it was on the basket, and we had this component at the bottom that basically shows you all of your totals and how much tax you're going to pay and all that kind of stuff. And you just really just push your data into it and displaying it. So it's really great for something like that because you can just push data into this one little component. But I'm not totally sure how we would do it if they all need to start talking to each other. I think honestly at that point you go, no, this is one bigger component.
I guess fundamentally how we built it, just quick. So the question was that you're working on a project right now that is trying to put lots of different components together. How do we get them all? How do we start them up? I guess. So fundamentally, we have the activity sits as the parent. Within that, we created custom views. So if you look at the layout file, you'll see the different views. But then when the activity starts, we will effectively call out to them and kick them off. But it becomes a bit of a, so they're very much separate with all their MVI loops, apart from you need that parent activity to start them off. And so if you were to look at, say, a method, you have 5 different custom views that were all following these new MVI loops, you'd have call outs to those 5 in your parent activity. So there's still some sort of parent thing going on there, and like Todd said, but then they are isolated, and then it becomes a pain in the ass to actually talk to them. So I guess for us, Basket, it became such a complicated screen, that's why we started doing it that way. I would hope that the rest of the screens of our app are way simpler so we don't have to resort to it. I appreciate it doesn't solve your problem, but yeah, that's the way we sort of did it. And I'm happy to share codes and things like that. Just reach out to me after. Yeah. Cool.
by the fact that we don't have any keyways. So I'm curious to see, was that a business-driven decision or an engineering-driven decision?
It was a business-driven decision, yeah. So
why am I surprised?
Sorry?
Why am I not surprised?
Yeah. So generally speaking, the web teams had moved away from having manual QAs for a while, but it hadn't affected the apps teams. And eventually that decision hit us, and I was quite opposed to it, quite vocally opposed to it. And we lost some good people, unfortunately. Some of them are here today. It was a real shame. But since they've gone, because it's forced us to automate everything and make it part of our development process, we have coped. I would say it's definitely made us go a little bit slower, and I would say we're definitely less likely to find these weird bugs that testers find, because they do all kinds of random stuff and they sit there all day like mucking around with your app. I'm not trying to downplay testing, I'm just saying, as a developer you go, here's my test case, it passes so everything works. You don't actually go, oh, I'll take a phone call with you through a transaction going through, which is what testers will do. So I think with that, we tried to do better, and it forced us to adapt. But since we have done that, which was about 6 months ago, I would say it hasn't materially affected us. So I would always like to have good QAs on things like automated tests, definitely. But we're getting by.
So yeah, I've always been a big believer that there's no bugs in my code, and I've found that if you don't have testers, there's no bugs in your code. So it's great.
Another way of looking at it is you have the users do the test.
Your users can test it for you. We have a very low crash rate as well, so it didn't impact us a lot. Like, I'll sort of focus on quality from the beginning, and this kind of stuff that we think about a lot, we like to think it means that we're better placed to code without someone sitting there rotating our phones around.
Thank you.
I think that's probably it.
That's it? No questions? Okay.
Cool. Thanks for your questions.
Thank you.